So now the second method, that is thermal or temperature triggering of SCRs. The width of depletion layer of the SCR decreases with the increase in junction temperatures. Therefore, in SCR, when VA is very near, VA means anode voltage, is very near its breakdown voltage, the device is triggered by increasing the junction temperatures. By increasing the junction temperature, further the reverse bias junction collapses, thus the device starts to conduct. Third method of triggering or turning on method, nothing but a radiation or light trigger. So for light triggering methods, the SCRs are special terminal Nikes made inside inner P layer instead of the gate terminals. When the light is allowed to strike this terminal, the free charges carriers are generated. When intensity of light becomes more than the normal value, the thyristor starts conducting. These type of SCRs are particularly called LASCR or light activated SCR. See that here there are three terminals of the SCR marked here, that is anode A, cathode K and gates. And anode is made positive here, cathode is made negative here, junction J1, J2, J3 are marked here. See that this one is the light terminal, light energy from a light emitting diode directly following on the reverse bias junction J2. And if this process will be continued, then the light intensities are also responsible to attain VBO or forward backward voltage. Then also the SCR start conducting by breaking the reverse bias junction J2. So this principle works by a particular device, that is light activated SCR, so called as your LASCR. Then fourth method of triggering, nothing but your dV/dt triggering methods. In this method, when the device is forward bias, junction J1, J3 are in forward biasing mode, junction J2 is in reverse biasing mode. Junction J2 behaves like a capacitor due to the charges existing across the junctions. If voltage across the device is V and the charge by the Q and capacitance by C, then IC is equal to dQ/dt. That is the rate of change of charges, nothing but current. Q is equal to C into V, dQ/dt, take derivative of both the sides, then dQ/dt is equal to C d derivative v/dt of C into V. dQ/dt nothing but IC, that is charging current, that is equal to C dot derivative of V with respect to t plus V into derivative of C with respect to t. That means as C is a constant factor, values will remain constant, that's why derivative of the capacitor C, which will be 0. So the expression becomes IC is equal to C dV/dt. Therefore, when the rate of change of voltage across the device becomes large, device may turn on even if the voltage across the device is small. Then come to the last method of the triggering, that is nothing but your gate triggering methods. This is most widely used SCR triggering methods. Applying a positive voltage between gate and cathode can turning on the forward bias thyristors. When a positive voltage is applied at the gate terminal, the charge carriers are injected in the inner P layer, thereby reducing the depletion layer thickness. As the applied voltage increases, the carrier injection increases, therefore the voltage at which forward backward voltage occurs decreases. See that here in gate triggering method, anode is made positive and cathode is made negative, we are giving the gate circuit closed. In that case, we are giving the supply voltage to the gate terminology, making gate positive and cathode negative. And this process will be continued. If you are increasing the gate voltage gradually more and more, then it will inject or throw the carriers, means electron carriers and hole carriers, into the reverse bias junction J2. Whenever the carrier density around junction J2 increases further more and more, then also reverse bias junction J2 breakdown after getting forward backward voltage. In that case, see that here voltage is V1, then voltage is V2, then voltage will be your V3. These are the forward leakage current gap is marked here. This one is the increasing nature of the current. Whenever I1 current increasing, the voltage value is suppose V2. IG to get current, the voltage value is suppose your V3. IG is equal to 3, then voltage value is equal to something. So in that case, we see that the voltage value decreases from maximum value to the minimum value. The current value rises from minimum value to the maximum value. This one is the on-state current. In that case, all the junctions are in forward biasing mode, and the SCR behaves like a single current carrying conductor, as I'll tell in the last chapters. So in that case, see that two currents are marked here. One is latching current IA, second one is a holding current IL. Already know that latching current IL is responsible or associated with the turning on process. Means the minimum value of current through which the SCR remain in on state. Then IH is the holding current. The holding current is associated with turn off process. Means it is the minimum value of anode current below which it must fall for turning off the device. The entire operation shown in forward conducting mode at the first quadrant of the VI characteristics curve. Then come to the third quadrant of the VI characteristics curve. In that case, let us making anode negative, cathode positive. Let us we are giving the gate voltage here. In that case, we see that if you are applying the positive gate voltage, then the SCR does not responding, and it is as remain before. So VBR is the forward breakover voltage, VBO is the forward breakover voltage, VBR is the reverse breakover voltage. Then come to another article of the chapter 1, that is switching characteristics of the SCRs. The entire switching characteristics of the SCR study in a curve drawn between the anode current IA with respect to time t. The anode current IA we have drawn here, the curve here. This is the blue line curve and marked here, that is solid curve. The curve, entire curve is divided into two different segments. One is your on process, second one is your off process. First of all, we have to study about the turning on process. In that process, the entire turning on process is now divided into three different sub-intervals. One is your TD, turn on delay time, TR, rise time, TP, the spread time. What is the TD, turn on delay time? The time taken to rise the anode current from 0.9 Ig to 0.1 IA. Then come to the TR, this one is the rise time. The time taken to rise the anode current from 0.1 IA to 0.9 IA. So the rise, in this case, the current start increasing, and the SCR goes from forward blocking mode to forward conducting mode. Then come to the third segment, third interval, that is TP, that is the peak time or spread time. The time taken to rise the anode current from 0.9 IA to IA. After reaching this point, the anode current value will maximum, the SCR which will be turned on, all the junctions are in conduction mode, and IA value will maximum here, shown by a solid straight line parallel to the time axis. Then come to the second category or second characteristics, that the turn off mechanism of the SCR. The entire turn off mechanism of the SCR now divided into two different intervals, that is TRR, reverse recovery period. Second one is your TGR, that is the gate recovery period. So after turning on the device, we know that after SCR turn on, the gate loses control over the SCR. If you are increasing the gate current further more and more, then the SCR remain as remain before. So for turning off the device, it is remember that the carriers present around the junctions may be removed. If the carrier density is more and more, then device always in on condition, because all the carriers in that case are in favorable for the conduction. So for that reason, our aim is to remove the carrier around the three junctions. For that reason, for removal process, let us provide some reverse voltage through the anode and cathode terminal of the thyristor. If you are giving the reversal voltage, then it will start removing the carriers. At junction, at the time T1, instant T1, or start removing the carriers, we are just applying here the reverse voltage to the anode and cathode terminals. Whenever the curve reach at the instant T2, it is observed that around 60% of the carriers are sweep out. And then whenever rest amount of the current carriers may be 0 at the T3 instant. But still it is observed that due to the presence of trap charges around the junction J2, that charge curve instead of 0 at the T3 region, it will be extend towards